Hey everyone, and welcome to This Explainer. Today, we're unpacking the massive, honestly fascinating history of Indian science and technology. But we're not just going to run through a dry list of ancient inventions. Instead, we're going to look at this chronologically, almost like we're tracking a series of absolutely crucial operating system upgrades for an entire civilization.
Because it really brings up a massive question, right? How exactly does a civilization transition from scratching notes onto ancient palm leaves all the way to launching highly successful, incredibly precise missions to Mars? To figure that out, we've got to explore how centuries of really rigorous empirical observation and just pure everyday practical necessity completely shaped this civilization's tech infrastructure.
To make sense of this sweeping historical timeline, we're going to break it down into 6 distinct eras. Ancient foundations and empirical minds, the Sultanate's practical tech revolution, imperial Mughal engineering masterpieces, colonial constraints and scientific defiance, the temples of modern India, and finally, the tech education engine. Let's see exactly how this technological infrastructure got upgraded at every single step.
Starting off with Section 1, Ancient Foundations and Empirical Minds. Let's look at how the early base code of Indian science was written.
And what's crucial to understand here is that this early foundation wasn't built on mythology. It was built on strict, rigorous observation. Think about Aryabhatta. He was basically the grand navigator of ancient science. He introduced heavy mathematical concepts, like the Jaya, which is the sine function, to literally track the cosmos. He used objective math to theorize that the Earth rotates on its own axis. And he explained solar and lunar eclipses, not as, demons swallowing the sun, but simply as shadows cast by the Earth and the Moon. It's just pure data.
And that empirical mindset spread everywhere, illustrating the highly practical foundations of ancient India. It was all about solving real-world problems. You've got Aryabhatta calculating pi with staggering accuracy. Over in healthcare, guys like Jivaka were setting up professional clinical practices, while Sushruta was out there pioneering incredibly complex surgeries. We're talking early plastic surgery and cataract removal. Oh, and the metallurgy? Absolutely next level. They created wood steel and structures like the Iron Pillar of Delhi, which has literally been standing outside for over 1,500 years without rusting. Just incredible engineering.
We also definitely have to talk about the 11th century polymath al-Biruni. He was essentially the first great cultural bridge between the Islamic world and India. He brought this brilliant scientific temper to his studies, actually learning Sanskrit so he could objectively document all this Indian astronomy and math. The guy even calculated the Earth's circumference with mind-blowing accuracy. But he wasn't just there to flatter anyone. He famously pointed out the insularity of Indian scholars at the time, basically warning them that their reluctance to learn from outsiders was starting to hold back their scientific progress.
Okay, let's fast forward to Section 2, the Sultanate's practical tech revolution. We're upgrading to the medieval era here.
The arrival of Central Asian tradition sparked this massive shift in everyday, day-to-day technologies. The contrast is just staggering. Moving from delicate palm leaves to actual 13th century paper manufacturing, that made running a massive government bureaucracy possible. Replacing slow hand spinning with the charkha, the spinning wheel, completely supercharged textile production. And the introduction of the sakya, the Persian wheel, meant farmers could suddenly lift water from really deep wells with minimal effort. This was a massive system upgrade that totally rewired the economic landscape.
In fact, the historian Irfan Habib calls this period a literal technological revolution. The state was acting as this huge consumer of new tech. Architectural engineering was completely flipped on its head with the introduction of the true arch, the dome, and high-quality lime mortar. Suddenly, builders could construct these massive, super durable, column-free spaces, think giant mosques and imposing forts, faster than ever before.
Which brings us right into Section 3, Imperial Mughal Engineering Masterpieces.
The Mughal Empire took those practical tools from the Sultanate and just supersized them. They poured unbelievable resources into showcasing visible, tangible power. They mastered incredible structural engineering with techniques like Pietra Dura stonework and double domes. Creating total masterpieces like the Taj Mahal. To dominate global trade, they built colossal ocean-going merchant ships out of native teak wood, ships so tough that even European traders preferred using them. They also heavily upgraded military tech with massive cannons and totally revolutionized agriculture by integrating new Portuguese crops. Imagine Indian food before they brought in the potato or the chili.
But here's a really fascinating duality. While the Mughals were absolute masters at practical engineering for luxury and war, historian Irfan Habib points out they basically ignored pure theoretical science.
Remember, Europe was going through a massive scientific revolution at this time, but the Mughals, they felt zero economic pressure to invent labor-saving automated machines. Why? Because manual labor in India was incredibly cheap and plentiful. So they totally passed on game changers like mechanical clocks or the printing press.
Moving into Section 4, Colonial Constraints and Scientific Defiance. This is where the dynamic shifts entirely.
The British colonial government reorganized India's entire infrastructure purely around resource extraction. But those very constraints forced a fierce, new kind of scientific defiance. And that all comes to a head in the year 1930.
In 1930, physicist C.V. Raman became the first Asian scientist to win the Nobel Prize in Science. The takeaway here is absolutely brilliant. It's the triumph of human intellect over fancy infrastructure. So Raman is traveling by ship, staring at the Mediterranean Sea, wondering why it's blue. He completely rejects the accepted idea that it's just reflecting the sky. He goes back to India, and using incredibly cheap, basically homemade lab equipment, he discovers the Raman effect. He proves that light actually changes color and wavelength as it scatters off molecules. It was massive proof for quantum theory, and it proved to the entire world that Indian minds could lead cutting-edge global research from Indian soil, regardless of colonial limits.
Let's step into Section 5, the Temples of Modern India.
That exact same fierce scientific temper from guys like Raman became the absolute bedrock of Jawaharlal Nehru's vision for an independent India. Post-independence, the country was dealing with massive, widespread poverty, so the state urgently weaponized science to achieve strategic autonomy. They started building what Nehru called the Temples of Modern India. That meant establishing the first IIT in 1951, driving the massive Green Revolution in the 60s so the nation could actually feed itself, testing nuclear capabilities in 1974, and launching the space program with the Aryabhata satellite. And look at where those foundational investments are today. They've blossomed into towering pillars of modern tech. ISRO is globally famous for its incredibly frugal yet highly complex missions to the Moon and Mars. In transport, you have these massive indigenous engineering feats, like the Konkan Railway, conquering brutal terrain, which paved the way for today's high-speed Vande Bharat trains. And in telecom, India built a completely unique digital public infrastructure. It literally allowed millions of people to completely bypass the whole desktop computer era and leapfrog straight into a hyper-connected, mobile-first economy.
But bringing us to our final section, Section 6, the Tech Education Engine. None of that modernization happens without human capital.
You literally cannot launch rockets or build digital networks without the underlying hardware of human minds. Tracing this timeline is a fascinating journey. It starts with ancient global hubs of scientific learning like Nalanda. Then, during the colonial era, the 1835's Macaulay's Minute clamped down on that, actively designing an education system purely meant to train administrative clerks. But Indian visionaries fought back, founding research hubs like IISc in 1909. And post-independence, the government took that nationalist response and scaled it up to create the world-class IIT and NIT ecosystems.
However, we have to look at the whole picture, and historian Ramachandra Guha offers a really critical critique here. He points out that this created a dual legacy. Yes, the state poured massive resources into building these top-tier islands of excellence, which successfully produced global tech leaders and created incredible social mobility for the middle class. But this sometimes happened at the direct expense of upgrading basic primary school education and rural infrastructure for the wider masses. It built a very unequal pyramid, and for decades that inequality fueled a massive brain drain of top talent heading straight to the West.
Which leaves us with a final, really provocative thought to consider. We've traced how India upgraded its civilizational operating system, from ancient metallurgy and the Persian wheel, all the way up to lunar rovers and digital public infrastructure. But as India continues to aggressively power the global digital economy, the big question is this: can those brilliant islands of excellence expand enough to actually lift up the rest of the nation? It is a fascinating, ongoing journey of evolution, and the next chapter is being written right now. Thanks so much for joining me on this explainer.